Okay, let's talk about inverse functions. So an inverse function turns the process of a function inside out. So that basically means that it undoes what the original function does. So if f of x turns 3 into 7, then that means that the inverse of f of x turns 7 back into 3. So notice here how whatever is being put into the function is what comes out of the inverse function and vice versa. Okay, now we know what an inverse function is, but how do we find the inverse function of a function? So step 1, we're going to replace the f of x with y. So we're going to get y equals 3x minus 4. Step 2, we're going to swap the x and y, so that gives us x equals 3y minus 4. And then step 3, we solve for y. I'm going to isolate 3y by adding 4 on each side. So that's going to give us 3y equals x plus 4, and then divide each side by 3, and then we get y equals x plus 4 all over 3. And the fourth and final step is to just replace the y with inverse of f of x. Okay, now it's your turn. Pause the video and try to find the inverse of this function. 1 f of x equals 1 over x minus 2. Okay, so step 1, replace f of x with y. Step 2, swap the x and y's. Step 3 is to solve for y, so I'm going to swap the x and y minus 2 here. So we're going to get y equals 1 over x plus 2. And if you're wondering why I could just swap that, that's because the product of x and y minus 2 is 1, so these are interchangeable. And the last step is to just replace the y with inverse of f of x. So we get inverse of f of x equals 1 over x plus 2. Okay, now let's talk about graphing inverse functions. So here we have f of x equals 2x plus 3, and let's try to find its inverse function. So replace f of x with y, and then swap x and y's, and then solve for y. So we end up getting y equals x minus 3 all over 2. So that means the inverse of f of x is x minus 3 all over 2. And we can delete the work here. So now we have two functions here, and they're inverses of each other. So we're going to plug both of these into Desmos, and let's see what they look like. So if we were to combine these two graphs together, they would look something like this. And if you were to look at the relationship between these two lines on the same graph, you would probably realize that they are actually flipped over the diagonal y equals x, which is a linear line that goes through the graph like this. So on a graph, a function and its inverse are actually mirror images across the line y equals x. So you flip one of them over the diagonal and you get the other one. And you might even realize that the y-intercept of f of x is 0, 3, while the x-intercept of the inverse of f of x is actually 3, 0. And this doesn't just apply to intercepts. If you actually grab any point on this f of x line, for example here, you're going to get 1, 5. On the inverse of f of x, you're actually going to get 5, 1. And even here, you get -3 on the inverse function. Actually, this isn't a really good example because they're both the same number. But anyways, on the f of x equation, you also get -3 because, you know, they're the same number. So you can't tell that they're swapped, but they are. Notice how this applies to what I said at the beginning of the video about inverse functions, where the y of the function corresponds to the x of the inverse function, and the y of the inverse function corresponds to the x of the regular function. Now, one last thing before you go, it's very important to note that not all functions can have an inverse function. For example, if we have our stereotypical parabola here, there is actually no inverse function for it, because if there were to be an inverse function for it, it would look like this. And that's not a function, because it doesn't pass the vertical line test. So if we were to grab a ruler and put it on this inverse function, we would see that it is not a function, because there are multiple y values for the same x value, and that makes it not a function anymore. And we can actually tell that a function isn't going to have an inverse function if it doesn't pass the horizontal line test. So you can see here that f of x doesn't pass a horizontal line test because there are two different x values that actually correspond to the same y value, which makes its inverse function have two y values that correspond to the same x values, because inverse functions have their x and y's flipped. So in order for a function to be able to have an inverse function, it has to be 1-to-1. Now 1-to-1 means that not only does it pass the vertical line test, it also passes the horizontal line test. And by having a function pass the horizontal line test, that means that its inverse function will still be a function. So functions are actually sexist, they're actually misogynistic, and they actually don't like women, and I'll show you why. If x refers to women and y refers to men, just hear me out, okay? A function can have so many different women can be with the same man, and it's okay. You can have f of 3 equals 2, f of 4 equals 2, f of 17 equals 2, for all I care, it's still a function. But the second that an x value has even another y value, it's not a function anymore. Suddenly, the entire thing is busted. So basically what functions have taught us is that a man can be with multiple women, but a woman cannot be with multiple men. And I don't even know why they're teaching this us in school, because this is sexist. So that's how you memorize your function rules. So yeah, I hope you enjoyed this video and I hope you learned something new. Thank you so much for watching, and I will see you in the next one.